This week we're going to be working in Scratch once again, but this week we're going to take a look at solving math problems. And math problems are considered algorithms. And so if we look at Webster's dictionary, we find that an algorithm is a procedure for solving a mathematical problem in a finite number of steps that frequently involves repetition of an operation. And so we're going to see how that definition actually applies directly to math problems that we're going to work on. And so let's take a look at a sample problem, and I'm going to show you how to structure this and build this in Scratch. First of all, you're going to notice that the first thing that the problem talks about is a variable, typically with a letter. And so we're going to have to set up a variable, and that variable is also going to be used to start our problem running. So when the Z key is pressed means I am writing a program triggered by the operator, or the variable Z. So I'm going to go to variables, and I'm going to make a new variable, and I'm just going to name it Z today. So when Z is pressed, what do I want to do? I want to say the value of Z as it changes. So what's going to make it change? Well, like we saw in our definition, there's a number of steps that involves repetition. So the first thing I have to do is give my variable a value. So I have to set, and notice the definition set, or the specific problem says set. So I'm going to get my set from my variable area. I'm going to go to Z, and I'm going to give it the value as specified of 75. The next step in the problem is to repeat 5. So 5 times I'm going to repeat something. So we have to do a repetition block, and we have to go find a repeat block. So in our controls, we can find a repeat block. And we want the repeat times blocks. So we want this top one that says repeat. Currently says 10. Our problem, I believe, wants us to repeat 5 times. So I'm going to change that number to 5. And the next step is they want us to say Z. Now what I'm doing when I say Z is I'm actually saying what is the value of Z at this point in the process. So to say, I go to my looks command, and I grab my say, and I want to do it for 2 seconds at least, because I want to know what is the actual value. How can I see what is changing in Z? And then I grab Z as a variable and replace the statement, or the hello block, part of the block. And then after I say that, and notice my indentation. The say is indented, the change is indented. So since both of those are indented, I know that they're inside the same loop. And that's going to be real important when we look at another example. Now I'm going to change Z by -5. So once again, back in the variables, there's a change statement. And I'm going to change Z by -5. Now, what I'm wondering is, can you figure out what the answer is without me even running this code? What is actually going to happen? Think for just a second about that. So what's going to be happening is 75 is going to reduce by 5 each time through the loop, which is going to run 5 times. So watch the Scratch cat, because the Scratch cat is going to be doing the say, and the value of Z is denoted up here. And that comes in handy just to watch. In fact, I can put it right over here. We can see it happen at the same time. So now all I have to do is press the letter Z on my keyboard. Okay. And so the final value of Z is 50. Now, interesting things happen when you change numbers and change the order of numbers of the change commands and the say commands. You may get slightly different results. So what you see was not the starting point. You saw it after -5. So it started at 70, and now it's counting down to 50. So you have to think about your order of operations and what's really correct and which one's actually giving you the right answer. You know, as a mental check, I can say 5 times -5 is -25, and I would go 50 is my right answer. So it's not that you cannot do the problems in your head, because many of you will be able to noodle through these problems. The issue is we're building algorithms, and algorithms are mathematical representations expressed in code, at least for our purposes. So we want to look at our worksheet and build these problems. Excuse me. Now, as we look at the first one, we're going to set a to 72. So I'm going to get a set. I'm going to create a variable and set it to 72. I'm going to use an if statement and an operator. The operators are in green, and I'm going to use a greater than. And I'm going to say ABC. And notice that this ABC is indented, whereas the one at the left margin is not inside the if loop. If it's at the left margin, it will always execute. If it's inside the loop, it'll only execute when the loop is true. So we're going to leave it real simple and take a look at these. This one might say ABC, but will always say DEF. This requires C to be a certain value, and it's testing it twice. So it'll say it each one either once, or it'll say both of them, or it'll say neither of them, depending on the value of C. And so the same thing holds when we test multiple variables. But sometimes we want to do what's called a nested loop, where we're testing one variable inside a loop of another loop. And so one of your challenges today is to set up this problem. If h is greater than 80, and inside of that, test if I is greater than 85, say DEF. Then notice this if statement is back to the left margin. So it's a separate if statement. So you have two ifs. They're not nested. These two ifs are considered nested because this if is indented or contained within the first if. The second if is a standalone. So we don't know whether we're going to have DEF or GHI or both of those things said until we program this. So that's going to be your challenge for the day, is to work through this set of problems and program each one of them as an algorithm in Scratch. Yes, I know you can answer them in your head. It doesn't matter. That's not the lab for today. The lab is to program the algorithms so that you can do it in code. Because as we move through our other programming languages this year, your challenge is most often an algorithm that needs to be programmed within Scratch. So you can see problem A here. If I come back to my keyboard and I press the letter A, the Scratch cat says DEF. Now this variable was Z only, so I can turn that off by going to variables. And if you hadn't noticed, if this checkbox is on, that's display the variable or turn it off. If I want to see what A is going to be for my current problem, I had A set to 72. So when I press A, the cat says DEF. And so that means A is not greater than 72, so I did not say ABC, I only said DEF. So each of these problems needs to be built based on the first variable in the problem. So A, B, C, D. This one will run based on D, this one will run based on F, and this one will run based on H. You won't use the second variable to launch the code. You'll just use the variable within the algorithm code itself. So jump off, get some problems written, and do your submission of your Scratch with these problems, each solved within your Scratch code. And we'll look forward to working on some more problems tomorrow.